Hello guys, welcome to this new video on machine learning. What I'm going to show in this video is in the last video we had seen something about the SAM model which was used for identifying objects in image and masking them, and it was fairly accurate, right? So what I tried is that in this video I tried to combine the SAM model with a stable diffusion imprinting model and tried to do imprinting on the objects that are identified by the SAM model. So the code is ready in front of you. Just we'll run the code and we'll go through every each and every point and try to see how this entire thing works. So firstly, we will just connect it and make sure that we have GPU connected. So it's the GPU is connected. I'll just zoom it for you. Okay, so these are some basic dependencies since we are using Colab. So we have to make this flag as true. Then we have this SAM dependencies, which we had also seen in the last video. This is the main SAM model. Then we are making a directory. We are getting some images, and this is the path for the width edge SAM model. That is the by default weight for the SAM model. So what Colab will do is that it will download everything on your drive locally here, and then we can run it. So let's wait up till all the things are downloaded. So now it is downloading the SAM model weights. So it's a pretty big file, but things work fast on Colab luckily. Cool. So now the SAM model weights and everything is downloaded here. So once they are downloaded, what you can do is that up, you can just call the SAM model registry and SAM predictor from the segment anything, and then you can just register the model with the model type as well as the checkpoint which we have declared here, and the device is equal to CUDA. So since this is a PyTorch model, you have to pass it to CUDA. So we'll just run this code. Cool. So this is completed. Now there are some other basic dependencies like NumPy, Torch, Matplotlib, and CV2 because we are going to play with images. Then these are three functions, that is show mask, show points, and show box. So by the way, I have not written these functions. I got these functions and every part of this code from the SAM models GitHub page. So if you want to check that out, I'll leave the link in the description below. So these are the three methods that they have given. Now, after that, we just simply read the image that we downloaded above. So in the images folder, we got this dog image, which we just downloaded above. So let us read the image. Then we pass the image to the predictor object that we had called in the SAM registry. So this is the predictor object, right? So once that is done, let's try to see the figure, how the dog actually looks like. So this is the image that we want to do the imprinting on. So now we identify the label on which object do you want to do the imprinting. So let's try to do the imprinting on the dog object here. So the dog object lies at the array of 200 comma 400. So yeah, there you see this is the object and this is the star. Okay, so then predictor dot predict, and then we pass point coordinates as well as point labels and multi-mask output. So this is how the mask of the object looks like. Fine, right? So now what we'll do is that we'll resize the image into 512 into 512 so that we can run it on the stable diffusions imprinting. Then we check if NVIDIA's device is there or not. So we have the NVIDIA device here, which is the one. So this command actually gives you the details on the CUDA version, which is their driver along with that. So this is the CUDA version driver and other things that are required for this stable diffusion model to run. Then we have to install the diffusers library and make sure that this is the version of the library. If this version is not present, this code won't work. So we try to install the diffusers. Along with that, we install the transformers, SciPy, FT, FPy, Xarray. These are some other dependencies to make this code work. Cool. So then we have to import the torch as well as the diffusers. From the diffusers, we need to import the diffusion pipeline. So from Stability AI, this is the main impending model that we'll be working on. And in that diffusion pipeline from pre-trained, we are just calling the model. So if the model is not installed, it will install it for by default, and then it will pass to the CUDA object. So then we just run this thing. Then the pipe is actually passed to enable attention slicing to save some GPU in exchange of small speed decrease. So once this is done, then we are able to do the imprinting very easily. So let's wait for this to complete. Okay, so now since we wanted to change this dog object to something else, so we just need to give a prompt here. So stable diffusion to imprinting works by prompt engineering, by providing a prompt. So what we'll do is that replace the dog with a tiger, and we also can provide a negative prompt. So here we'll write he should be happy. So let's try to see what output stable diffusion gives. See, it replaced the entire dog with a tiger image. So this is so cool, right? Like the tiger looks angry also. So whatever you want to do with the prompt, you can do it here. Let's say instead of the dog, we just replace it with a cat. Okay. See, this doesn't look exactly like a cat, but it is able to replace objects in your images, and you can play around with this prompts and try to see like how good is it, or what can be the perfect prompt to get something out of it. So see, the dog is replaced, but the object doesn't look like a cat, but still it was able to replace it. So this is the power of stable diffusion to imprinting model. And you can let me know in the comment section how you can get same object every time you run the same code. So if you want to do that, and what is the better prompt, like how to write the prompt in a better way so that every time, let's say I want to get a cat, this image doesn't look like a cat, right? It has definitely changed the original dog, but it doesn't look like a cat. So what should be the prompt? Cool, right? So this video, I hope that this video has added some value to your learning curve, and feel free to leave your thoughts and comment in the comment section below. See you next time in a different video. Bye bye.